and we have a cylinder, right? And they give us a piece of information that we might probably have to use, as this here. The volume of the sphere is 4/3 pi r cubed, and they are telling us to use pi as 22/7. Now, let's see what do they want us to do. They said determine the volume of the ratio VB to VC, where VB is the volume of the ball and VC is the volume of the container, right? So look at what we have here. So you have the ball. Now the volume of the ball, VB, they already give us a formula for the volume of a sphere, right? Because a sphere is a ball. So it's 4/3 multiplied by pi, but in the question, they want us to take pi as 22/7. So we're going to use 22/7. So we're not going to use the 3.14, right? Use exactly what they tell you to use here. So that's 4/3 multiplied by pi multiplied by r cubed, right? So we don't know what the radius is. They're telling us the radius is r. So we're just going to leave this as r cubed over 1, right? So let's work this out here. Now that's why your fraction calculator is important, right? So 4/3 multiplied by 22/7, and that is giving me 88/21 r cubed, right? That's the volume of my ball here, right? That's the volume of my ball. So all I'm doing here is just using the formula that they give us to come up with an expression for the volume of the ball. Now, what else they want? They want the volume of the container, right? Now, the container here is a cylinder, right? That's what the ball is inside. It's inside a cylinder. Yesterday in class, we saw what the volume of a cylinder is. It is actually pi r squared, which is the circular part of the cylinder multiplied by the height. So this is how we find the volume of a cylinder, right? So they're calling it container. So VC is that. So pi in this case is 22/7 multiplied by r squared. We don't know what is r, but 1 second. Right, is r a little better. So it's r squared over 1 multiplied by the height. Look, the height of the cylinder is actually 4r. So this is 4r over 1, right? So now let's get this as a fraction now. So this is on top, it's going to be 22/4 is going to give me 88 r cubed over 7. 88 r cubed over 7. Yeah, that's looking about right. Any questions about what I just did there? Or are we good? So this first expression here, this is the volume of the sphere, the volume of the ball, right, which is 88 r cubed over 21. And the volume of the container, which is the volume of the cylinder, is 88 r cubed over 7, right? So now let's see what they want us to find. So they want us to determine VB over VC. So let me just write those things here. So VB, right, which is the volume of the ball, is 88 r cubed over 21. So this here is 88 r cubed over 21. And the volume of the container, we got that as being 88 r cubed over 7. So this is 88 r cubed over 7, right? And the question wants us to work out VB divided by VC, right? So all we're going to do, we're going to take VB and divide it by VC. So this is 88 r cubed over 21 divided by 88 r cubed over 7. When you are dividing into fractions, remember we changed the division sign to a multiply sign. So this is going to be 88 r cubed over 21. So we have to change the sign to a multiply, and we need to invert this here. So this is going to become 7 over 88 r cubed. Now, if you look carefully, what's going to happen now? This 88 is going to cancel with this here. This r cube is going to cancel with this r cube. This 7 will go into this 21 3 times, right? So my final answer here is simply going to be 1/3. So, do you all follow this one?
Yes, sir.
Yes, sir.
Um, Janelle, did you manage with this one in the exam or?
Not really. This get me so upset when I see them bring it like this.
Yeah,
No.
they didn't give you numbers, so that
Yeah.
that
And still to a point here, it's still confusing me a bit because I'll have to go over and watch this properly now.
Yeah, so basically, you see, when you have to do questions, when they give you pi as being 22/7, try to work everything as a fraction. So that's what I'm doing here, working everything as a fraction. And again, the fraction calculator is going to help you, right? Especially with working out this. So the ratio in this case here, VB over VC is 1/2, right? So that's the answer there. The next part now, part 2, they said if the volume of the ball is 179.7, calculate the volume of the container to the nearest whole number. All right. Now, this is the funny part, right? Because if you had gotten this wrong, then you're gonna get this piece wrong, right? So we know that VB over VC is equal to 1/2. That's what we just worked out, right? VB over VC is 1/2. So now we're gonna have to use this in order to work this part out. So they said the volume of the ball, so that's VB, is equal to 179.7 centimeter cube, right? That's the volume of the ball. They want us to calculate the volume of the container. So all we're going to do now, we're going to plug in this VB into that equation. So 179.7 divided by VC, because if you notice, that's what the question asking for. What is the volume of the container? Is equal to 1/3, right? So I told you guys in class, when you have an expression that looks like this, all we need to do is to cross multiply, all right? So we're going to say VC by 1 is going to give me VC, and then that should equal to 179.7 multiplied by 3. So we just cross multiply. That's all we do. So it's 179.7 multiplied by 3. And they want it to the nearest whole number. And if you work out that to the nearest whole number, it's going to be 539 cm cubed. So that's how we're working out this piece. So we're using the answer we got in the previous part to work this out, right? Any questions about this one, or are we good? You okay with this one?
Yes, sir, I understand.
All right, cool. Now the thing is, CXC kind of lenient, right? So even if you had gotten, let's say you got the wrong ratio here, right? Then you could have still gotten marks with this one here if you had the correct working. So the ratio could have been wrong and they will still give you marks. I've seen CXC give away marks, like give marks for like the student just put the formula and they give the marks, right? Right, so that's A. What is this one here now? So let's see what they say now. Given that the base area of the container is 38.5 centimeters squared, using the volume of the container calculated in the previous part, find the value of R. Right, so I could understand why this question will give people trouble, right? So let's get let me get this diagram back here for you. So let's take that here and let's look at what they're saying here, right? So we just worked out this 539 here represents the volume of the container, right? Which is 539. So the volume of the container, remember the container is a cylinder, right? And that worked out to be 539 cm cubed. That's the volume of the container, right? Now, they are telling us that the base area of the container is 38.5 centimeters squared. So you know what they're saying, right? They're saying this area here, this circle that you see in here at the bottom, right? Remember yesterday when I took the paper and I made the cylinder, there's a circular piece at the bottom. So what they are saying is that that area, that circular part there, so that area here is 38.5 cm squared. That's area, right? Now they said using this information now, we want to calculate the value of R. Can anybody tell me how am I going to find R in this case here? All the information has been given to us. We know the volume of the container. We also know the base area, right? How are we going to find that value of R?
Divide by 2. I don't know. Radius.
All right. So okay, let me ask it a different way. How do we find the volume of a cylinder? How do you do that? We did that yesterday, and I kind of mentioned it.
Area.
You'll have to find the area of the circle.
And
then oh gosh, I think you have to multiply by the height.
Yep, you multiply by the height. So the volume of a cylinder, right? So this is what they're trying to see if you know in smart. The volume of a cylinder is actually pi r squared, which is the area of my circular base, multiplied by my height. So this is what we're making use of here in order to figure that out. So you know the volume, the volume is 539. The volume is 539, right? Now this pi r squared here, what they've actually done, you see this figure here? That's the area of the circle. So we don't have to calculate anything. That pi r squared is actually 38.5. This is pi r squared. So we don't even have to calculate anything there. So this is going to be 38.5, right? Multiplied by my height. What is the height of the cylinder?
4.
4R. 4R is the height of the cylinder.
Yeah,
so
4R.
So this is 4R. So now I have an equation here that I can use to figure out what R is. So I'm going to just rewrite it. I'm going to put 38.5 multiplied by 4R is equal to 539. Therefore, R is equal to 539 divided by 38.5 multiplied by 4. So work out R for me here and tell me what you get. So using a calculator, just let me know what answer you get in for R.
So I can really calculate that too now because the calculator I have is a scientific calculator and it don't have ABC.
ABC.
Yeah, like 2.01 and like 539 over.
No, well, what you put
38.5.
What you put in your calculator there, it'll be your calculator brackets or no? Normal calculator.
It's that brackets, but it's not a calculator you have there, you know.
Oh, no, but that's okay. What you can do, right? So here what? You see when you have something like this, just do 539 on top. You can't do anything there. Work out the 38.5 by 4 first.
Is it 3.5?
Yeah, I get a 3.5.
Yeah, 3.5.
So 154. And when you work out this R here, you're going to get 3.5. And this is a, right, so that R there has to be in centimeters, right? So the answer is 3.5 centimeters. All right. So that is, we still on question 1, and we still, this is measurement. Now measurement is what I'm doing the form 4s right now, right? So that's part B. Why is there an next part B here? What's going on here? Oh, okay. Right, so this one here now, this looks like a sectors question, right? The diagram not drawn to scale shows a slice of pizza in the shape of a sector, right? With center O and radius 18 centimeters, right?
So,
Uh-huh.
I don't mean to cut you across, but you see that first question?
Yeah.
I literally saw everybody in that room watch one another. And everybody, like, they were sweating at the same time. This is no lie.
Uh-huh.
But yeah, for the first question, but then when I come in like this here, so well, then we start to settle in. But for the first one is the first question, we mash us up, you know.
Yeah. Yeah, this first one wasn't that straightforward. I could see people getting in trouble with that.
This posed real challenge for, and it had about 20 of us in the room, and literally everybody I make contact.
Uh-huh.
Yeah.
Let's hope what they bring in a few weeks time. Let me hope that it's a little easier, right? I feel this is just my opinion. I feel it might bring some linear programming question to them. I just feel so. As inequalities, plotting inequalities, I feel they're gonna bring one of that. And well, obviously, more than likely they're gonna bring measurement. Because so far, every single people we did had a measurement question. All right, so let's see this one here now. What do we have to do here? So the first thing they want us to calculate the area of the slice of pizza. You all know how to work this out? I literally just did this with the form codes. You have a sector, and they want us to find the area of this slice of pizza, which is a sector. Do you all know how to work this out?
Yeah, I know how to work it out.
All right. And by the way, this particular, now remember, a sector is a fraction of the whole circle, right? So there is a formula to find the area of the sector. And by the way, this formula is given to you in the exam. So area of sector, right, is equal to theta over 360, right? Because remember, whole circle is 360 degrees. So if the sector is only a fraction of the circle, this number here, the angle divided by 360, that's my fraction. And the area of a circle is given by pi r squared. Why am I writing here? So the area of a circle is pi r squared, but a sector is only part of it. It's a fraction of it. And that fraction is simply my angle, which in this case is 40 degrees, right? So it's going to be 40 degrees divided by 360 multiplied by pi. But what we're going to do in this particular question here, we're going to take pi as 22 over 7. Right? Because we're still in part A of the question, and they told us to take pi as 22 over 7. Multiplied by my radius is 18. So this is 18 squared, right? Now, one of the mistakes that students make is that when they're working out this problem, what they do is forget to do the squaring part of it, right? I saw the form 4 was making the same mistake. So work this out for me and let me know what to get for your answer. Now, the reason why I'm trying to make you work it out, I want you to get accustomed to using a calculator. Students have calculators and they still have problems working out questions because they're not sure how to use the calculator properly. So tell me your answer when you get it, right? I have an answer here already. Anybody work it out there?
113.14.
Yeah. So we're gonna put 1. What did I get? 1. Right? They didn't tell us how many significant figures to use or how many decimal places. So if you put this, that's fine. If you just put 113, that is also fine as well. Right? So 113.14. That's what we get in here. So that is the area of the whole thing, eh? Right? So make sure you understand that. That's the area of this whole thing, the whole slice. Right? So this is our formula. That formula is given to you in the exam. So that's all we're doing there. So that's part 1. Let's see what they have for part 2. The shaded portion of the slice of the pizza is cut off. So the shaded portion is cut off. Calculate the area of the portion of the pizza that is cut off. So let's take a piece of this here and let me show you what's happening, right? So they're taking this. So the question is saying that this piece of the pizza is being cut off. So this piece here is being cut off. Can somebody tell me what is the name given to that shape or that piece that we cut off?
Sector.
No, the whole thing is a sector, but that shaded piece, what do they call it?
The segment.
It's called a segment, right? So in a circle, I'm going to just give you all a recap here, right? So this is a circle, right? If we draw, and this is my center here, right? If we draw a line from here to here, right? That is my radius. If we draw a line from here to here, that is called my diameter, right? But if we draw, let me just draw over the circle so you don't get confused, right? If I just draw a line here, right? That divides the circle into 2 parts, but it's 2 unequal parts, right? That line is not a diameter. That particular line here is what we call a chord, right? This is what we call a chord, right? I've seen just recently, I think it's a 2019 paper, they had a diagram like this and they want you to name these things. So this is a chord, and this piece here is what we call a segment, but we call, because it's smaller, we call it a minor segment, right? So the name given to this part of the shaded, this part here, the chord is dividing the circle into 2 unequal parts, right? The smaller part is called my minor segment. So this is my minor segment, right? And this part here is my major segment, right? So these are terms that you need to know. So this piece here, that this shaded piece here is what we call a segment, right? So this is a segment. Now this is a typical paper 2 question, right? So this is nothing out of the ordinary here they're giving you here. So in order to get the area of that segment, can anybody tell me how am I going to do that?
So you'll have to use the sign rule.
But before you give me any formula, how am I going to find the area of that segment?
Yeah, find the area of the triangle.
Right.
Minus the area of the sector.
Right. So we using the area of the sector first because the sector is the bigger piece, right? And then you're going to subtract the area of the triangle, right? So first thing in your mind, you need to look at the question and see what they're really trying to answer. So fine. So they want the area of the segment. So if you find the area of the whole sector, that's a slice of pizza, and we subtract the area of the triangle, then we're going to get the answer, right? So we already worked out the area of the sector. That's this figure here, right? So what we're really missing, we need to figure out what is the area of this triangle here, right? That's what we need to figure out. Now, if you've never seen this formula, you need to know this formula. We are accustomed here in area of a triangle is base by height over 2, right? But there's another formula we can use to find the area of a triangle. If we know this here has to be 18 centimeters, this length here, A to O has to be 18 because that's also a radius. Whenever you have a triangle and you have 2 sides, and you have the angle in between, there's a formula we can use. So the area of the triangle what's the name? Let's call it something. Let's call it OAB, right? Is equal to, so this is what the formula is. It's a half multiplied by my two sides, which is this 18 and this 18. So it's a half by 18 by 18 by sine of my angle, which is 40 degrees. Sine 40 degrees, right? So let me just show you this here. So this is the triangle. The general formula is this. If I have a side here, A, B, and I have this angle here, which is theta, the area of this triangle is a half by A by B by sine theta. So if you never saw this formula, you need to know this formula, right? I can't remember if this is on the formula sheet. It may be on the formula sheet though. So that's the formula I'm using here, right? So it's going to be a half. Oh wait, I wrote it already. So let's use the calculator to work that out. So it's a half multiplied by 18, multiplied by 18 again, multiplied by sine 40 degrees. And what I'm going to get here is 104.13 cm squared. So this here is the area of my triangle, right? So that's a formula we need to know. So the area of the segment, so the area of segment, right, is equal to area of sector minus, right, I can't fit all that here, so let's say put it next time, right? Area of triangle. So the area of the sector, we know that is 113.14. So that is 113.14. Subtract the area of the triangle, which is 104.13. And that's going to give us 113.14 minus 104.13. And what I'm going to get is 9.01 centimeters squared. So that's